So hello everyone, again welcome to the very interesting lectures. So till now, whatever the things that we have accumulated, okay, all those knowledge of computer vision, whether it is a pose estimation for action recognition, whether it is a YOLO training for object detection, whether it is understanding the entire CNN architecture, each and every point, okay, we knew each and every point from the training till the monitoring part. Okay, now from this video, the trail of video that we will be seeing now, it's basically the more inclined towards or tuned towards the implementing all these things into the real life practical scenario. Okay, whether it is a analytics, whether it is a parking management system, whether it is like counting an object, whether it is a cropping an object, blurring an object in an interested reason, like understanding the queuing management system. Okay, so we will cater each and everything into many different videos of the real life video. I will take and walk you through each and every examples which is actually needed in order to get more insights of our learning. Okay, so from now, without wasting the time and without making this video too boring, so let's try to go into the Ultralytics documentation. Okay, so in the Ultralytics, if you see in the solution part, you will get a lot of different solution even in the repo also, right? So if you go into this Ultralytics, one second, this Ultralytics solution get, right? So you will get a lot more different use cases here. Okay, so let me just increase the font size so that you can actually see. Okay, so inside this repo, if you go, right, if you go in the solution part, so you will see a lot more things. You will see that how to basically like generate the heat map, right? Then how to do the object counter, how to do the instant segmentation, how to do the distance calculation. We will going to implement each and everything into our real life video. Okay, how to do the speed estimation and other things. Okay, so let's just start with the first one, which is like analytics.py. Okay, now let me tell you that what is basically the logic. Okay, so let's say that we have a video. Okay, over this video, if we wanted to do the analytics, okay, let's say in some business understanding, in some business use case, if our client wants the entire 24-hour surveillance, the analytics of entire 24-hour surveillance, right, then how do we actually going to provide them? Okay, so we have like line graph, bar chart, pie chart, different kind of plotting through which we can actually show our analytics. Okay, so let me just hop back into the code and let me try to picture my agenda for today's, right? So if we go to the analytics.py file, okay, let me increase the font size also, right? So if we go to this analytics.py file, okay, anyway, you will find all this repo in the Ultralytics documentation, as well as I will also make some changes and then try to publish it. Okay, so that you all can try to make the project by yourself, right? So if you go to the analytics.py file, right? So inside this analytics.py file, you just need to import one computer vision OpenCV libraries, which is like the version 2 CV2 libraries. And then the other thing is from the Ultralytics import solution. Okay, from the solution, you will get a lot more things. So here, let's say that I wanted to, let's say, capture the analytics part. Okay, when I say that I wanted to let the capture of the analytics part, which means that in whichever video, let me show you the video as well, right? So let's say this is my testing video. Okay, these are, let's say, my testing video. So these are the testing videos, some airport convoy, right? These are testing video of some airport, like the conveyor belt, right? Then the other thing is like these are the testing video of some parking allotment. Okay, so we are going to see each and everything. Okay, these are some Indian highway road scenario. Okay, here. So let's say that if you wanted to do these kind of analysis, then how will you do that? Let me pick any video. Okay, let me pick this video and let me just copy this path. Okay, and then what I'm supposed to do, go and then try to replace my video over which I wanted to do the analytics. I hope you get it, right? So let's say that over this video, I wanted to do the analytics part, right? Okay, over this video I wanted to do the analytics, right? The video is containing a lot more car and the car is like moving forward in the highway, right, and other things, right? And this is basically the video writer. So I hope you get it, right? So from video writer, what I'm supposed to do is that, let's say that whatever the analytics that I'm getting, right, so I am supposed to write on some kind of a video outlook. Okay, over this I am actually writing, so I am actually using this cv2.video writer library. Okay, over this, what I am doing, I am supposed to showcase all those analytics which is actually presented either in the line, either in the bar graph, either in the pie chart. Okay, now after this, you are supposed to call one more object from the Ultralytics solution, which is like solution.analytics. Okay, So if you go inside this Ultralytics, right, so you will find the solution. So inside this solution you will find analytics.py file, okay, and all the logics has been written over here, okay. So I will tell you that what is basically the logic here, so that you don't have to like put your mind into it. So basically the logic is, let's say that over the period of time, okay, I wanted to do the analytics of all the bounding box that I have actually captured, okay, I have already detected. So let's say that in one frame I have detected, let's say 10 bounding box. In the another frame, let's say that I have detected the 14 bounding box, okay. So in this way, as the time goes forward, right, then I am supposed to do the analytics of the bounding box of the defined classes which I am supposed to count, okay. So let's say that here from the solution.analytics I am supposed to like showcase the result. So that is why I am putting the show parameter equals to true. I wanted to do the analytics of line first, and then I am actually using the YOLO 11 n.pt file, okay, which means that I am supposed to use the pre-trained model, okay. If you have actually trained your model on your own custom data set, you can actually try to put your .pt model here, okay. Then let's say that I wanted to like do the analytics of, let's say, the 2, which means 2 is basically what? 2 is basically the annotation in the Coco data set. It is mapped to the car classes. So if you really wanted to see this, let me show you, right? So let me show you what it is. If you go here, right? So let me just go and type, if you go and type this Coco YOLO 11 class mapping. So if you go to all, if you go to Coco dataset, then you will find the mapping here. See, the Coco is like the dataset which actually the YOLO 11 has been trained on is on Coco dataset on, let's say, 80 classes, okay. And out of these 80 classes, so let's say that I wanted to do the analytics of just a vehicle class, which means the car class. So for car, I will be putting the key map, the key value as 2. That is why I'm just keeping here 2, okay. If you wanted to do the analytics of person, you can actually do that, okay. Now again, so what I'm doing, and let's say that this is the bar graph analytics, okay. So for now, let's say that I am only supposed to like represent the, let's say, the line graph analytics, okay. So I have written the line graph analytics code down so that you don't have to do anything, okay. Or let me try to like do the analytics of first line first, okay. So let me just do this, and let me just, okay, right. Now let's do the analytics, right? So now what I'm supposed to do, I'm supposed to run this file, okay. It is nothing, right? It is nothing. I'm just like writing, like running this, like I'm just calling this analytics method from the solution class. That's it, right? So analytics, if I just go and .py file, so you will see the analytics over here. See, as you can see that as the frame is moving forward, then you are actually like seeing the analytics of total number of count of the car classes, okay. So you will see the analytics like this, okay. Now let's say that if you want to see the analytics of, so it will keep on going, okay, it will keep on going frame by frame, okay. Let's say if the video is actually running on 20 fps, 30 fps, this is your analytics, and this you can actually like refer to your client as a business analytics solution, okay, that what has actually happened in your 24-hour surveillance camera. You can actually like show the real time analytics to them, okay, and not just like the line graph, even the bar graph also, okay. So let me just hop back to bar graph as well, okay. So let's say that if you wanted to show the bar graph, you can actually show the bar graph as well, okay. So let's say this one, let me write this one, okay. And if you wanted to show the bar graph, you can actually show the bar graph of, let's say, this one. And from here you just need to like pass one more thing, which is here, just put the bar graph, that's it. This is supposed to be line. Let me just uncomment this, okay. This is basically my bar graph, and let me just uncomment this part. I just want to show the bar graph, that's it, right? Now I don't want to plot this one, so I will just comment this out, right? Again run this part, right? So now what you will see is that you will basically try to see the analytics of, let's say, the car, okay, that whichever car you will be getting, so you will be getting the like analytics per frame, okay. So you will see that like the initially the analytics is like 7, 8, 9, 12, 10, okay, then 9. So this is basically the analytics of bar graph. Okay, now let's say that if you wanted to like see the analytics of, let's say, pie chart, okay, then what you're supposed to do? Nothing. You just need to like write this thing, right? So analytics bar, similarly, let's say that I wanted to write the analytics of pie chart. Okay, so analytics, and let's say I'm going to write this pie chart. Okay, again the solution dot analytics method, and inside this method, let's say that I wanted to detect the person as well. Okay, I wanted to detect the person and some other class. So what is actually one is mapped to? Let me see. So one is mapped to bicycle, motorcycle is also there. Okay, so let me map the motorcycle as well. Okay, so let me map the motorcycle as well, which is like up to 3. Okay, let me force code this thing. Okay, now let's run it again. Okay, so this is analytics.py file. Okay, so this is like an analytics.py file. So let me go there and write this part. So this one, I think that's it. Let me run it again. It has to be analytics py. 1 second. So it has to be something, this one, result py, and then analytics results py dot this one. Cool, now it's working. So you will see the current analytics of the bar graph. So this is basically the pie chart. Okay, before it was bar graph, before that it was line. Okay, and you will see the frame by frame analytics, right? And you can actually like refer and like find out so many business understanding from this pie chart. Okay, you can just compile the pie chart or a bar graph or a line graph of each and every frame, and then just try to like represent it and just try to like pose it as a business solution. Okay, so in this way you will find a lot more different things, right? So in this way you will get a lot more insights of the video, okay, of the analytics part, okay, which you can actually use from the Ultralytics inside the solution class called the analytics method. Okay, so this was only up to the analytics part at how to analyze the video. Okay, suppose if you have a CCTV camera, you have a RTSP link, right? And let's say you have 24-hour camera surveillance, and you really wanted to do the analytics of, let's say, PPE, helmet, vest, and other safety equipments of your worker. Okay, and let's suppose that if your model is very precise to detect each and everything, okay, and if you wanted to showcase the entire analytics, right, you can actually use this method from this class provided by the Ultralytics solution. Okay, so in this way, and also like the logics as well, right, that each frame by frame you wanted to like take count of each and every classes. Okay, so inside the for loop you can like just try to count each and every classes, so it is not very difficult. You can even simply write the logic by yourself. Okay, so yeah, this was all about this video, all this analytics part. Let's move to the another use case. Thank you. Again, welcome to the another set of use cases, which is like the heat map generation, right? And why heat map is very, very important in a lot of business use case, because you will get a lot of business understanding, a lot of business solution from it. For example, if I going to tell you about what if some government is actually like giving you a contract of making a night vision camera. Okay, and apart from making a night vision camera, suppose that if like in the camera goggles, if you really wanted to like display the heat map of the crowd gathering, okay, then it would take your problem to the very next level. Okay, so that is why these kind of solution will going to help you a lot, right, in making any of those solutions. So let's say that if you have a night vision solution for object gathering, you can actually try to use it. If you really wanted to like generate the heat map for a crowd gathering, you can actually use it. Let's say that in a medical term, so you have actually trained your own YOLO model for detecting some kind of a different small molecules, right, or a small micro disease, and if you really wanted to like inhale the behavior of like how they are actually like gathering and how they are actually like making the combination from one other tissue as an other cell, you can actually try to by making the heat map, you can actually try to understand the concentration of the behavior of the molecules, right, the micro molecules. So you can actually try to use the heat map in any of those use cases. So let me show you one of those use case, then I will show you other use cases also. Okay, so let's say the logic is very simple. The logic has to be that anyway you have a 2D image, okay, you have an image with some height and width which is equal to the resolution, okay, and let's say that in that image what you actually wanted to do is that, let's say that you actually detected some of those objects based on number of classes, okay, let's say that you wanted to detect the person, so the person class has to be 0, okay, and then let's say the YOLO model has detected all these person in the one frame, okay, frame by frame. So in the one frame the YOLO model has detected all the person, okay, and if you really wanted to draw the heat map, okay, so the more number of color intensity implies to wherever there is a more number of box inclusion it, or wherever the more number of bounding boxes is. So like if the boxes are actually overlapping to each other, and let's say if the more than one bounding boxes are overlapping to each other, or even there is a very least overlapping, or there is no overlapping, right? So in this way you can actually try to figure out that what is the concentration, what is the pixel level concentration in that region, okay, and with that you try to like map it into the heat map color conversion, okay, that we have already seen in the computer vision series in the image processing, okay. So the same thing, okay, so what I'm going to do is that I'm supposed to call this from the Ultralytics solution, and from the solution I will be calling the heat map as a method, okay, and inside this method I will be calling the color mapping, the model which I'm supposed to call, and then this show is equals to true, okay, and the exact the code is actually the same thing. Okay, so let me just try to run over this video. First let me show you the video. So this is basically the retail store video. You can see that some customers are actually like buying something, and someone is like roaming here and there, okay, and if you really wanted to like understand the analytics of these things, okay, so how can we do that? By using the heat map generation. So I will just try to run this code, right? So let me try to run this code, this one. So as you can see that this is the heat map, okay, so this is the heat map of, let's say, objects, all the objects which YOLO pre-trained model is basically detecting. So it is detecting the person, it is detecting the basket, shopping baskets, it is detecting the some other object which the YOLO model is already trained on. Now let's say that I really wanted to like skip all this detection, and I only wanted to concentrate over the person, okay, I don't want other things to like avoid, I want to avoid all the things, okay, so I want to just concentrate on person. So what I will do is that I will just go here and just write the class map equals to person, that's it, right? So if I just wanted to like detect the person, so I will just map it to class equals to 0, 0 means person, okay, and then I will run it again. So you will see that it is basically let me run it again. Okay, let me run it again. So cd computer vision Python heat map generation, right? And this one, see, so now it is basically concentrating more over the person rather than getting confused by the other object, because other object I have not given, right? As you can see that at the cache counter, so there is a more involvement of the person like going like concentrating in one particular region. That is why the heat map is like a pretty higher, okay, so it is more reddish. Why? Because the count of the bounding box detected person is way higher compared to this area, right? So in this way you can actually try to like generate the heat map according to your use case. Now suppose if someone gives you that I don't want to detect all this heat map around all the region, I wanted to detect the heat map like in a one particular selected region, okay, so okay, so like if the client told you that he wants to like detect the only one particular region, he wanted to avoid all this region, okay, he wanted to just concentrate on one particular region. So it is also possible, because you can also try to give the region point. Now what is region point? So region point is, again, this is your, let's say, one frame, and if you really wanted to like detect and focus your algorithm in one particular region, in this region, that's it, you want to skip other region, so you need to give the coordinate, you need to explicitly define this the region coordinate into the code, okay, that is why this is actually the region points, okay, these are basically the region points. So how do you actually like define the region? It's very simple, right? So the code that which I'm supposed to do is the same thing. So I will be just reading my video first frame. So let's say that I am reading my this one, right, retail store. I will go copy path here, okay, don't worry, I'll provide the code, so you don't like, you can actually like do it, because we have done a lot more times, right? We are actually like from the OpenCV library, we are actually capturing the first frame, okay, and then we are actually saving it into the frame, this one, right? So if I go there, so this frame is getting saved, right? So this is my first frame. This is my first frame, and let's say that I wanted to like just separate this region. Okay, I want to isolate this region, that's it. Only this region I wanted to generate the heat map, other region I want to avoid it. Now how can I actually do? I will be using the RoboFlow, as simple as that. If I go I hope you are following me. Okay, RoboFlow polygon, let's say zone. Okay, so inside this RoboFlow polygon zone, just go inside this and just drag and drop your project. Just go here, and where is your frame? This is your frame, right? So okay, I need to go to the file location. This is the issue. I'll go here, LMS experiment. I will go this computer vision solution, or it was there in the frame.jpg. I will just drag and drop over here. That's it, right? Now inside it, you wanted to like isolate the region. Okay, so what I will do is that I will use this polygon mode. Okay, so inside, so there are many other region as well, so I will use the polygon mode. Inside this, I just wanted to, let's say, like focus over this region, so I will just draw the region. This is very interesting and this is very cool also, right? See, I have drawn out the region. I have the coordinate. I will just paste this coordinate in my code. That's it. So I'll just copy it here. I will go to my code. Okay, and I will go to my file. So let's say that this is my heat map generation file, and let's say that my region that I have just copied it, this one, right? So yes, this is my region. Okay, and in that region I wanted to enable, so I want to enable the region as a parameter inside my heat map method. Okay, again nothing, it's very simple. Okay, so I have just like explicitly mentioned only my interested region in the frame. Okay, and then I will just give the region and pass this parameter, and I wanted to detect the class as person. Okay, then again what I will do, I will just run my code here. So I'll just go here. So let me use some new terminal. Okay, let me go computer vision solution. Let me run the heat map dot generation py file, and you will see this one. See, okay, now you will get the count only around this region. Okay, that's it. Okay, the model is like basically like skipping all these things, so you can actually see that how many person are actually inside it, right, and how many person are like outside the region and other thing, right? Try to make the use cases. Okay, so this is what my intention to show you the heat map as well. Okay, with the region and without the region, and with class and without class. So this is the solution mostly related to retail analytics. Okay, now let's move to the another solution where I will show you some other use cases. Thank you. So now let's understand about the very crucial application of computer vision is finding out a distance calculation. Okay, and the practical use case would be anything. Why? Because let's say that whenever you wanted to calculate a distance, okay, between the two objects, okay, then how do you basically calculate it, right? That is the number one question, and that is also like provided by the Ultralytics solution repo. Okay, I will like walk you through this as well. Okay, so let me give you the glimpse of like today's video, like what I'm supposed to do. I'm supposed to first of all like finding out the localization. Okay, then size estimation. Then let's say I wanted to understand the seam. Okay, or let's say that I wanted to understand the collision between the two objects. Okay, all these things are a very distance related problem, right? Because let's say that if you are actually like trained your any object detection model, right, and between the two different object, if you really wanted to find out the distance between the two different object, okay, and there would be many other scenario as well. Let's say in medical term, if I wanted to tell you, right, so in the medical term, let's say that there is something called as a quarantine zone. Okay, so if you really wanted to like calculate a distance between the patient and the quarantine zone distance, okay, and if the patient is actually like at the very safest distance or not, okay, so that could be the one problem. The other problem that you might occur is the vehicle collision avoidance problem, right? That you have a two different vehicle of two different class ID, and if you really wanted to like find out the distance between that, okay, then how can this problem can tackle or solve this issue, right? So the point is that again, like in the Ultralytics solution repo, you will find out the distance calculation. Okay. Now the logic of this would be that it is basically calculating the pixel level distance. Now when I say about pixel level distance, now what does that mean? It means that distance is not as accurate as like we see completely in the real life scenario, because of course the camera is actually the CCTV, right? The camera is IP camera, and it is actually like the video is streaming on that camera. Okay. So unless you are not changing the resolution, okay, the video is actually feeding into your system, so you are actually like calculating the pixel level distance. Okay, just understand the distance may not be accurate, but as accurate to get you a good understanding about the two different objects, so that you can actually find out a good approximation of what the entire scenario. Okay, so let me go through the code and then just show you the implementation part. Okay, so let me first see that like where I can like apply this kind of problem. See, I have this conveyor belt problem, right? And this is the one of the issue, right? Because the conveyor belt problem, let's say that some of those suitcases are damaged, okay, and some of these suitcases, let's say if we really wanted to find out the distance between two of these suitcases, okay, so how can actually like try to find out. And the other scenario would be, let me see one other video. Okay, I think we can actually like try to find out this video as well, right? So this is like the truck unloading or loading video. Okay, and if you really wanted to like calculate the distance, let's say that these two vehicle, okay, so if I really wanted to find that whether the loading scenario is actually being occur in a very spacious environment or not, okay, and if you really wanted to like calculate the distance between these two motorcycles, then is it possible in this scenario to find out the distance? The answer is yes. Okay, because we can actually like find out the pixel level distance. So let me just hop back to code and then show you, right? So let me just use this airport conveyor belt. If I just copy this path, just put it here. Okay, right? And now let's say that I really wanted to like not detect anything. That's it, right? So class, I am just keeping it, and again I am again following the same thing. What I am following again, I am just like from the Ultralytics class I am importing the solution, and inside, let's say, the from the solution I'm actually calling this distance calculation method. Okay, and all the logics has been written over inside this. Okay, the logic which I have already told you that it is basically the pixel level distance. So let's say that just understand the logic. That's it, because the logic is already been pre-written by the Ultralytics team. Okay, just understand the logic. So let's say that I have one object here and I have another object here. So can I just find out the bounding box coordinate or the ID of this object? The answer is yes. Can I able to find out the object ID of this object? The answer is yes. Can I able to find out the center coordinate, and can I able to find out the center coordinate of these two objects, right? And then if I get the center coordinate means what? Center coordinate means center pixels. Okay, the center pixels value. So can I just find out the center pixel value of this object 1 and this object 2, and using the Euclidean distance we can able to find out, because as this the same object with the same tracking ID will actually move forward in the same present frame, right? Then I can able to calculate the distance, right? Then the question might occur that what if the tracking ID change? Okay, if the tracking ID change, then there will be an issue, because this one has to be like connected with the same tracking ID which is already there. That is why I am actually using this tracker, which is like bot shot tracker. So what will happen is that suppose that you actually trained your tracker very much, so that in any of this video get pixelated in between, the pixel get cracked, right? So that tracking ID should not get changed. Okay, the tracking ID should remain unchanged. Okay, that is why you should train your tracker, object tracker, in such a way so that even though there is a breakage in the video, you will get a good tracking ID. Okay, and if you get the good tracking ID, and if you able to like detect the object with the stable tracking ID across the video frame over the period of time, then it is well and good. You can actually try to use this distance calculation problem. Okay, so again I am just passing the parameter as model. I am actually passing my model, I am passing my tracker, and then again I am like using the CV tool library. I am just opening my video camera, okay, which I am already captured it from like CV to video capture. I am opening till the video is like getting indent. Okay, and then I'm actually capturing frame by frame, and after each frame I am actually giving it inside the distance calculator method. Okay, inside this method with this, along with this method, so that I can get the result. Okay, so without wasting any time, let's try to run it, right? So if you could see this one, right? Now if you really wanted to like calculate, you can actually calculate. See, so this is basically like the distance. So I am just clicking with my mouse, right? So let's say that if I just wanted to calculate between these two suitcases, I can see you can actually see the pixel level, right? As this conveyor belt is actually moving forward. Okay, I am able to calculate a distance between two suitcases. Okay, so this one. So you can actually try to find out in this way the distance calculation. Let me try to use some other example which I have already showed you, the truck unloading part, right? So let me just copy this path here and let me just paste it. And the code is very simple. Like all chairs to Ultralytics theme, so that they have actually like written all this logic so that the user can get a very compatible solution, right? So this one, and then let me give the class as well, right? So let me give some class. So let me give something as, let's say that I want to detect something as 2 3. Okay, 2 is like something for, 2 is for car and 3 is for motorcycle. Okay, and if I really wanted to like calculate the distance, I can do that. Let me just try to run it again. Right, so this is actually the motorcycle. Let me use this one. See, this is basically the pixel level distance. Okay, I have just clicked my like cursor from this 2, and then 2 is what? 2 is basically the tracking ID of that detected object. Okay, and 8 is what? 8 is the tracking ID of this detected object. Okay, and this is actually detecting one perfect class. So between these two, I would able to get the pixel level distance between two vehicle. Okay, so there are many use cases. You can actually try and come out with lot more use cases and then try to do it by yourself. Okay, so this is basically the scenario for distance calculation provided by the Ultralytics solution in the computer vision project. Okay, so you can actually try it out in so many videos. Write in the comment, come up with so many entire use cases, and then try to make it public so that everyone can get used of it, right? Thank you. So again, welcome again to the another very interesting lecture. So today we are actually supposed to do the instant segmentation. Okay, so first of all, let me show you that what is segmentation. I think we have given a lot more different examples on the before while we were actually covering up the foundation course. Okay, so let me just show you that in like types of segmentation. Okay, so if I just types of segmentation in image processing, you will see that this one, right? This picture. Okay, so you will see that there are like many different type of segmentation. Okay, so this is like the semantic segmentation where like I am just segmenting the object on object class wise. That's it. So this is the person class, so this is actually segmented in one class with the red color, and this is like the vehicle class, so it is segmented on the other class with a different color, and these are trees and roads are some other class. Okay, so this is semantic segmentation. Okay, which is like not generally used in the market. Okay, the most important segmentation that we are supposed to do is that these two, which is like instant segmentation and synoptic segmentation. So it is basically doing the pixel level plus class level segmentation. Okay, so you will see that the male is actually having some like another segmented color, the female is actually the another segmented color. So these two are actually like come in the category of vehicle, but this is truck and this is like the another shape. Okay, so in this way, that is why I wanted to cover this instant segmentation. And what is the use case? So let's say that in medical domain, in order to detect any tumor, okay, or any organs, because you have, let's say, the microscopic image, right, and you wanted to detect the tumor, any organ, or let's say the cellular structure, so you can use, other than object detection, you can actually like use the segmentation so that it will try to microscopic view with the segmented output. Okay, or let's say that in a construction area domain, okay, or let's say that if you have a camera setup at the very nearer to the concrete structure, and if you really wanted to like find out the cracks in the concrete, you can actually try to use the instant segmentation as well. Okay, so there are other use cases as well. So again, let's hop back into the code, and then what I'm supposed to do is that for YOLO there is a, we are supposed to use the YOLO 11 and segmentation.pt model. Okay, so this is like I wanted to segment something, right? And let me just try to use this segmentation on which one, on let's say the person class, okay, or let's say the vehicle class, which one. Let me use this one. Okay, so let me use this video, or let me use some other video where there is like more concentration. Let me use the truck video. Okay, so this one, let me copy the path over here, let me do the instant segmentation, let me paste it. Okay, this one, and let me also try to give the class as, let's say, 0 for person. Let's say I want to just detect only person, that's it, right? Cool. So now these things are already set up. Again, the same thing, the same scenario. From the solution, I am supposed to use the instant segmentation. The instant segmentation, like the code, you will get it like from here, from the Ultralytics repo. You go instant segmentation, inside the segment, all the logics and everything has been written over here. Okay, and I have already like taken the session of how to do the CNN classification and other things. Okay, so you can actually refer to the previous video as well to get the conceptual understanding that how segmentation happens, right? Again, let's go back to the code, and if I just try to run it, python instant segmentation.py file, then you will see this part C. Okay, isn't that beautiful? Like the person is only segmented, and it is also having a tracking ID also with a confidence score. Okay, so this is like the result of instant segmentation, that first it is actually detecting the person, assigning the tracking ID, okay, as well as giving us the confidence score, as well as segmenting each person with the different color to the another person. Okay, so this is basically the result of instant segmentation. So you can try to use this. Okay, thank you. So again, welcome back to the another lecture. So today we are actually covering out the object blurring part, right? So because let's say that if you have actually IP camera setup, okay, and it is actually working completely fine, detecting the object, doing all this analytics and other things, okay. But if someone came and then asked you that, because it is like outreaching the privacy part, right? And someone say that, hey, so can you just blur out these classes, because I really don't want to show these classes on the screen. Okay, so how can actually do that? Or let's say that if you wanted to protect any privacy, or let's say in the media industry, right, which has let's say a huge chunk of live streaming video, okay, and some of those media, let's say, is covering in the region of government area, okay, and because of some rules and regulation you wanted to hide some building, you wanted to hide some official objects, okay, then how do you actually do that thing? Okay, so you can actually try to use the object blurring in that case. Now similarly, let's say that in the airport scenario, right, so if you really wanted to keep some streaming as a confidential streaming, you don't want to reveal their faces, right, up to the screen, so in that case you will be using this object blurring problem. Okay, so the solution that actually has been provided is that I will tell you the logic. So the logic is very simple. So let's say that in that one particular frame, right, you have actually detected the object, correct? Object detection means what? You actually get the detection of that particular class, you are actually getting the bounding box of the all four coordinate. Okay, now when you get the bounding box, then you are trying to like depixelate all this region which is present inside the bounding box. That is the very simple logic. Okay, what you wanted to do, you just first go and catch out that particular one class which you wanted to blur, and then inside it you wanted to depixel every of those like pixel, right, present inside the bounding box. In this way the object will get blur, so there will be blurring ratio as well, right? So you will like find the code over here which is like the object blurring, right? So object blurring, and the same scenario you can actually try to use it over there. Okay, again let me just try to use it in my current code. Okay, let me just try to clean my previous mess. Okay, now what I'm supposed to do is that I'm supposed to like blur something. Okay, so let me just try to like blur some image. Okay, so what image should I blur? So I have used these things, I have used okay, let me blur the car classes. Okay, so copy path, then there is object blurring. Okay, inside this, let's say that I want to blur this person. Okay, that's it. Now let me give the class as well. So the blur ratio is 0.5, which means half of the pixel it wanted to depixel it, right? And then let me just give a, so what is basically 2 for car, right? So again, then everything looks same. I don't want to record the video, so I just wanted to like comment this one and show it by using the cv2. That's it, cv2 dot im show, right? And inside this I wanted to like put this frame. One second, in the instant segmentation, this one, right? Object blur, object blurring, and then this has to be results dot plot im. That's it, right? Okay, now let's run it. Okay, so let me try to run it. See, you can actually see that all those car classes has been blurred. Okay, all these car classes has been blurred. Now you can actually like, can it use in lot of security camera? Of course yes, because you don't want to, or live streaming, of course yes. Let's say that suppose this is actually the live streaming part, right? And if you wanted to like channel this the streaming to the any news media, okay, and if you really don't want it to like they don't want the viewers to actually see all these confidential class, okay, then what you can do, based on class wise, like you can actually train the model by yourself or use the any pre-trained model and just try to use the blurring method. Okay, in this way you can actually blur all this region. So this is very interesting when it comes to the privacy part of using the computer vision in the privacy detection. Okay, so in this way you can actually do this thing. Thank you. So again, let's move forward to the another set of use cases. So today we are actually going to discuss about the zone monitoring. Okay, so let's say that in a region, if you really wanted to count any object, okay, then how can you actually count the object in your very interested region? Or let's say that if you have a region, let's say if you have a camera streaming from directly from the highway, okay, so from the highway point of view, if the CCTV actually capturing the two lane, okay, the one where the car are actually incoming, the other is where the car are actually going outgoing. Okay, and if you really wanted to count the number of incoming car and the number of outgoing car and actually display it in the screen, then how can actually do that? Or suppose that in a very crowd gathering situation, okay, or let's say in a where the CCTV is actually capturing some kind of a election campaign or some kind of a procession where public are actually gathering from coming from many different area, right? So if you really wanted to like understand that, okay, this is my hazardous area, so I need to like trigger an alarm so that these many crowd gathering, these many magnitude of public, I don't want in that one particular region. Okay, so how to actually generate the alarm from that? Okay, so we will be like going to implement all these things from the solution provided by the Ultralytics. Okay, the logic would be same. Okay, so let's say that I have one region. In that one region, if the object count is basically like increased above my threshold, then I will like trigger the alarm, or I will just keep the video moving forward. Okay, let me go back to the code. Okay, so here again I am actually supposed to use this one, right? Object counting.py. If you go here in the public repo, you would actually get it from here. See, object counter.py. So in this object counter, you are supposed to call this method. Okay, so from Ultralytics I am going to call the solution. From solution class I am going to call the object counter method, and inside the object counter method I am supposed to give my YOLO pre-trained model, okay, which is used to detect different object. Okay, so let's say that I want to detect all the objects, okay, in that region. So first of all I need to make the region, and I have already told you that how to make the region. First of all, let's say that which video is more suitable. Is this video suitable or this one? Okay, let's go with this video. Okay, this video actually you can see that there are so many cars are incoming and outgoing. Okay, and I really wanted to like find out the number of incoming car and number of outgoing car. Okay, how can I actually do that thing? So first of all I need to frame out the first frame. Okay, so I need to like capture the first frame. So what I will do is that I will just going to run this code, right? Again the same code that we have actually discussed a lot more before, right? So again this is the file location I am giving. Okay, and these things actually saved in my this is my first frame. So this is supposed to be my first frame. So I need to first like draw the region. Okay, there has to be some region, right? So I need to draw. So for drawing the region, what I'm supposed to do, I will be going inside my this RoboFlow polygon zone dot roboflow.com. Okay, and then inside this, let's say that I want to draw some region. So how can I actually draw it, right? So let's drag and drop here. Okay, and then let's select the line mode. Okay, and from this line mode you can actually like try to draw this region. Okay, so this is like my left coordinate, which is like the x and y axis, and this is my the right coordinate, which is like x and y axis. Again, the x and y axis has been originated from the top left corner, not from the so it has to be originated from the top, like the top left corner, not from the bottom left. I have already told you a lot more basics in the previous lectures as well. Okay, so I hope you get it, right? So I hope you get it, all these things. So just copy this coordinate and put it over here. So inside my this object counting.py file, yeah, this one. Okay, so I will just pass my region over here. I will just like put this video, and then I'll just try to run it. Okay, again Python, the same code with the different classes. That's it. Object counting.py, right? If I run it, you will see this one, right? So you will be able to capture these things, like so many cars are actually going, so number of cars are coming in, number of cars is going out, so you will get the exact count, right? Now let's say that I don't want to detect this other classes, I want to detect only car classes. So what I will do here is that in the class I will just give my car class, that's it, which is like 2 in my Coco dataset mapping, right? So this has to be 2. Again, Control S, let me clear it, let me run it, and you will see that all this car has been detected, avoiding the cycle, the person, the tree and other thing. Okay, and then you can actually see the number of car which is coming in, the number of car which is going out. See, the 3 car 1 2 3, again the 4 1 2 3 4 in this region, okay, and then these car are actually going out, right? So in this way you can actually try to make the use case from this, right? Now let's try to like derive some other thing, okay? So let's try to like detect some crowd gathering situation. So let me take this one. Okay, let me just try to, so this is like the CCTV camera view of some warehouse, okay? So let me just try to capture the first frame from here, okay? I will just again do the same thing, copy path. From here I will just capture the first frame, okay? So from here cv2.video capture, just delete this part, okay? This part I'm just going to delete it up to here, right? And then I'm just looking to give the path name, and this is my frame. So this is my first frame, okay? And I need to draw the like the zone, okay, so that I can actually detect the number of crowd gathering in that particular zone other than avoiding the other zone. So what I will do here is that I will just try to make this one. So 1 second, just a second, I will just try to delete this part. From here I will just drag and drop my frame. I will draw out my region. So this has to be my polygon region. So 1 second, third, fourth, fifth, okay, this is supposed to be my region. I will just copy it, right? Control C. I will just go back to my code, okay? Then this is supposed to be this one, right? Object counting in a region. So let me just, so there is, so you can actually try to give more than one region. So I'm just giving my only one region. So I will just try to give my one region, which is this one, right? Which is 198, and then 57, the other is 56, the other is 56, 313, the other is 595, this is the pixel value. I'm just giving the pixel value, right? And then 350, and the last is 546, and the last one is 58. That's it, 58, right? Now let me just this one, okay, and now everything looks perfect, right? So I don't need to do anything. Let me just detect the person. So let me just detect the classes, class or classes, just a second. It has to be classes, right? So classes equals to, and then 0 as a person, right? Is there anything else? Yes, my video. Let me give the video. Path as warehouse, copy path, just try to give it here, okay, and then Control S, and let's run it, right? Let's clear it, Python, and then this object counting, right? Object counting into, let's say, region.py. See, okay, so this is like in my one interested region, it is basically like capturing all the object, okay? Again I will run it again, you will see it, because that is very small video, that's why. See this one, right? So you can actually see that all those people are actually concentrated in my area of interest, in my area of region, okay? So in this way you can actually try and implement so many other use cases other than like counting the object in the region, going in and out, or like counting the concentration of any classes in that particular area of interest. You can actually do it, okay? So this is my agenda of like delivering this video to you so that you can actually implement the real life computer vision application on your business use case. Thank you. Now again, let's move back to the another set of solution, right? So in this video, like we are going to discuss about extracting the class wise object from the video, okay, or let's say from the live inferencing, right? And if you really wanted to collect any data, okay, class wise, let's say that from the live inferencing you really wanted to collect only the classes of car, and you wanted to put this into the folder, okay, because in order to like train any model you need a big chunk of data, okay? So why can't you just go and take the video, live video, and then you can just like try to segregate it into the different classes. Let's say that I have car classes, person classes, or let's say the bike classes or truck classes, and different classes, right? You can try to like segregate it into the different like folder, right? So how can I actually do that thing? So that is also one of the solution has been provided by the Ultralytics. So what you can do, I will just show you the demo so that you can actually get it, right? So what they are actually doing, again the logic is very simple. So in the same video, in the same frame, if I'm talking about, you try to detect the object class wise, and then try to fetch that particular class and put it into, and then save it into the representative folder. Okay, so let's say that this is my one video. Okay, let me take one video. Which one should I take? Hotel parking, highway. Let me take some video. 1 second. Yeah, let me take this hotel parking video. Okay, let me copy this path and let me try to give it over here, so you will get it like what I'm trying to say. Okay, and then classes actually do the crop directory. Let's say that I wanted to keep the crop directory at crop detection. Okay, this is my directory name. That's it. Okay, and then let me try to run this file, and everything is actually same. So here I am also doing the same thing. From the Ultralytics, I am calling the solution class. From solution and class, I am actually calling the object cropper method. Internally, the logic is same, which I have already told you, right? So object cropping, object cropping dot py class. So you will see that it is just processing my video, and all this cropped object will be present inside here. See this one, right? Isn't that interesting to capture all these images from the data set, right? So in this way you can actually try to use it, right? So let me just try to control C. So let me show you the video, that which video I have used. So I have used this one, hotel parking, right? So as you can see that there are many cars and other thing, right? I just want the data which is in the category of car class, right? So you can see that after running that like method, you can actually get all this data, right? Inside this, all this different data. Let me show you. So if I go here, right, inside this experiment file, computer vision solutions, crop detection, see these many data has been detected, right? Just from that one like inferencing. So it's very good way to, you can actually try to segregate the data class wise. So let's say that let's say that in future I have a very real live data set, and I wanted to like a construction camp, right? And my CCTV is basically installed there, and I really wanted to like prepare a data set of person, class, some bulldozer, and some other bricks, right? Some cemented area. I really wanted to like capture and segregate all this data into the different class name in a different directory. Okay, I can actually do that thing, right? So it is very interesting. So this I wanted to show you. Thank you. Again, so let's move back to the very another interesting video. In order to raise the security alarm, okay, just like a security notification into your email, how can I actually do that thing? Because in most of the cases you already know, right, that how to first of all crop the object into the region, and how to like raise the number of object count, how to detect the number of object in that particular area of interest, right? Now let's say that if you really wanted to like apply these things into some kind of a security surveillance camera, right? And if you have some kind of a suspicious zone, okay, and if you wanted to find out that, okay, if there is actually a number of object detected in that particular zone, if it is actually crossing my threshold, I should raise the security notification, or any other use cases, right? So it can have like lot of use cases, right? Enormous number of use cases. You can actually try to use it by yourself. So let me show you what is it, right? So if I just go here, and if I just go to the security alarm system here, you can actually see that you need to first set up something, right? So just navigate to your app password generator, which is like provided by the Google. Just try to go and press continue, right? And let's say that I will going to allow, and I will get some kind of a key. Okay, so in my mobile phone I will get some kind of a 9-digit, let's say alphanumeric character. Okay, so what I will do is that once I actually get that thing, I am going to paste it over here. Okay, I am going to paste it over this code. So the code which is provided in the repo, right? So this is my, let's say, email ID. Okay, whosoever is actually sending the email ID to, let's say, some manager or someone. Okay, and let's say this is basically a surveillance camera video. Okay, it can be any video, it can even your live camera video, live camera feed as well, right? Then what you're supposed to do from the solution, again the same thing, you need to call the security alarm method. Okay, inside that method, let's say that I want to detect only, let's say, the threshold of 3 people. Okay, if there is actually the margin crosses the threshold of 3 people, I should actually raise the security alarm with the evidence, right? So how will I actually do that thing? Again, just control S and try to. So if I going to run this, right? So here again the same thing, right? So I am actually giving the person class because I need to detect the person class. Similarly, you can able to detect so many classes as well, right? So in the person class, if I just going to give the class name as from 0, because 0 is like the YOLO Coco dataset mapping, so I just want to give you the person class. And if it is actually crosses the threshold, okay, if it is actually crosses the threshold, then I am supposed to run this part. Okay, so now what I'm supposed to do is that, so up to this part, I'm supposed to detect the person. Okay, so here I'll just going to give the person class in the Coco dataset mapping, you know, right? That for person, it has to be, the mapping has to be 0, right? And the same thing, right? So I am just calling everything entirely has to be same, right? And let me call one more time, right? So let me just try to run this. So you will see that only it is actually detecting the number of person. As soon as I just, you know, like try to run this code, right? In same, like in front of you, I am just getting the detection. See, right? So in my mobile phone, if I just going to call, see the person in the very first frame, it is actually detecting more than 3%. It means that it raises the security alarm, right? So in this way, you will get the security. So Ultralytics alert, 8 object has been detected in the very first frame, right? So in this way, it actually going to surpass the security concern. Okay, thank you. Okay, so now let's again start with the new use case, which is like the queuing management. Okay, so let's say that if you really wanted to use this into the real life system, so wherever, let's say that there is a conveyor belt, right? So there is also a queue. So the object, you are supposed to count the object which is present inside the queue. Okay, so for that you need to define the reason. Similarly, let's say that it can be actually used in a lot of hotel management system, or let's say in a parking management system, right? Where you actually like drawing the queue, and then all the car is supposed to be like systematically queue across one after one, right? So in this way, how can you basically solve this issue via computer vision? Okay, so we are supposed to use again the same thing, which is like the alternative solution queuing management thing. Okay, so let me just hop back to the code and show you. As you can see, let's say that I am supposed to take the airport conveyor belt. Okay, so if I just going to take, and inside this, first of all, I need to, like, in order to draw the reason, I need to first take the first frame, right? So as you have already following my previous lecture, so you would have known that I will be using the OpenCV video capture to like to extract my first frame from this video. Okay, so let me just copy path. Okay, and now this is where my frame is getting saved. Okay, so this is where my frame is getting saved. Okay, and now I need to first draw the reason. Okay, so let's say that this is my reason. So what I'm supposed to do is that again I will go to my RoboFlow and try to drag and drop this part, right? This image. Let me drag and drop here, and let me try to make a reason, right? So let me try to make a reason here. So where I should make, so that the queue should be good. Let me draw a polygon. Okay, so this one is better, this one, yeah, this is good. And I think this reason is well and good, right, for like queuing queue system. So this is the coordinate I got. Okay, I will copy this coordinate, I will paste it over here. So I will go to my queue management.py file. So again I will be using this from the Ultralytics solution. I will be using the queue manager. Okay, so inside this I'm supposed to pass my reason, right? So here actually I'm passing the reason. So let's say that this has to be my reason. So the reason has to be 133, 133, 169, 133, 169, then 9, 209, and then 178, 628, and then 349. So this is my the fourth coordinate, right? So 349 and 307. Cool. So now this is okay. So I have got my reason here. Okay, and from the queue I will be counting the object, right? So, and let me pass the video, this video here, this one, let me pass it. Okay, and I think everything is well and good, the same thing, right? Now what I'm supposed to do, again run this queue management.py file, and you will see the number of object count, right? So how many number of object is present inside the queue, okay, and how many actually are going out. So in this case you can actually try to use the queue management in any of the system. Now suppose that if you have something, let's say a big queue of people is standing in a hotel, right? And if you really wanted to make a computer vision solution which where the camera is installed at the top at some particular angle, and you really wanted to like properly like manage all these people, right, who are actually present in the queue, or who are actually like going into the another queue. Okay, so you can basically track that people. So in this way you can actually try to apply these kind of a thing into the real life implementation. Thank you.